Can anyone give us that number?
Yeah, it's do you want it rounded?
No, just give me at least 4 digits. Just give me 1 second so I clear this. What will I do without whiteout? I hope they never run out of whiteout. Okay, I'm ready now. Sorry about that.
So it's 0.151, and then the fourth digit's a 2, but the one after is a 6. So
Okay. Very good. So let's see what they want.
I got a different answer.
Okay. Let me double check.
I did 6279
Yes.
divided by 45. Oh, never mind. I messed up. Sorry.
I did that too, just a minute ago by copying to the table. Okay. It appears that it's correct. Okay, let me share our screen here. Good. So it says round to 3 decimal places. So we will enter 151, 0.151 to 3 decimal places. Okay, then part B. I'm assuming there is a part B. What is the probability that a randomly selected driver fatality who was 16 through 20 was male? So now they're twisting the same thing again. This time, knowing that, I'm going to stop sharing in a second. So this time they say, what is the probability that randomly selected driver fatality who was? So given that the person was 16 to 20, what is the probability that the person is a male? Okay, so male given this. Same thing, at the top the same, male, same, absolutely the same. The order in here does not matter. You get the same answer, but the denominator is a different story. So the numerator is the same thing, the 6279, but the denominator is the probability of 16 through 20. So 16 through 20 is this, over the total, of course. But I'm not going to copy the total because I didn't copy it here. So 8495. And if you have this for me, I'll copy it. If not, I will determine it. 6279 over 8495. I got 7391. Correct me if I'm wrong, please, at any point in time. And my apologies if that happens, when that happens. Okay, let's see. Round to 3 decimal places. And I found 0.739. 0.739. Is there part C? No, there isn't. Okay, move on.
Part C.
There is a part C. Okay. Yeah. Okay. Is a victim of fatal accident age 16 more likely to be male or female? Choose the correct statement below. So if we have is a big the victim of fatal accident is 16 to 20. So let's take a look at 16 to 20. If it's more likely to be, okay, 16 through 20. Let me stop sharing for a second.
I would say yes, because we just calculated for male, and 16 through 20 over probability of 16 through 20, we got higher than 5%.
So it is more because, right, we have 6279 over the total for 16 through 20. So this over this is definitely bigger than this over this. So we are only, right now, we are only looking at 16 to the, not at the grand total. So they're asking us, just look at this group. There is nothing else. This is our world right now. This group, this age group. Is it more likely for this age group to have a fatality that is male or female? Well, because we have 6,200 over 8,400, which is a higher percentage than 2,200 over 8,400, the answer is yes. Okay? And if we want to determine this, right, 6279 divided by 8495. Okay? It was the same number that we just determined. That's 73%, as Gabe said. 73%. But I just wanted to emphasize that now we are not referring our calculations to the grand total, but just to this. So one is 73% and the other one is 27%. So let's see what they say here. Yes, this is correct. Part A is correct. The driver is more likely to be female. No. More likely to be female. No. The driver is more likely to be male because the probability is less than. No. Very good. I agree with Gabe. Okay. Finally, we reach 15. Suppose that two cards are randomly selected from a standard 52 card deck. Yes. What is the probability that the first card is a spade and the second card is a spade if the sampling is done without replacement? Let's talk about that. Finally, we reach your question. So in 52 cards, we have 13 of each. 13 spades, 13 hearts, 13 diamonds, and 13 clubs. So the probability for selecting a spade, just one, is what?
Be 13 over 52.
That's it. 13 over 52, of course, it's 1/4. Because they're 1/4, 1/4, 1/4, 1/4. Good. Now we are selecting one spade, but this time we want spade followed by spade, no replacement. So the probability of selecting one spade, you already gave it to me, but let's keep it without not being simplified for a minute. So it's 13 over 52. We're not putting the card back in the deck. What would be now the probability of selecting the next one that is also a spade?
Be 12 over 51.
12 divided by 51. Does everyone understand this concept? Please,
Yep.
Yes, everyone? Okay. So now, yes, I can simplify and I get 4. I can simplify and I get 3. And
3
I
over
can
51.
and I can still simplify because the sum is 6, right? So I can still divide by 3. So 1, 7. I don't know if they want this or they want a decimal number or a percent. I have no idea. So this we'll see in a moment. 588. So let's go back. Round to 3 decimal places. So it's 0.059. 0.059. And this was without replacement. Now let's see. If the sampling is done with replacement, the probability that the first card is a spade and the second card is a spade is. So let's take a look. So these two events, right, are not independent because the probability changes after the first draw. But now the probability of spade and spade with replacement, the probability does not change. It's still 1/4 and the next one is still 1/4 if we put it back. So this will be 1 divided by 16. 1 divided by 16 is 0.0625. So let's see what they want. How do they want the answer? Round to 3 decimal places. So 0.063. 0.063. Okay. Good. Last question. Suppose that I'm going to copy the table so I can explain. So the top is age, less than 18, and then 18 through 44, and then 45 through 64, and greater than 64. And the totals are given this time. So this is private, this is government, and no. Okay. So 3 options. Okay, so total, so 185,430, 83197, 50830, and 319,457. Okay, so 2457, 38, 638, and 508. No, it's 509, sorry, and 59, 604. Okay, 50, 481, 10, 450, 10, 907, 71, 838. Okay. Okay. 73, 595, 10, 623, 29, 703, and the last one. Okay. Suppose that the data below represent in thousands. Okay, so all these numbers are in thousands. The type of healthcare insurance coverage for people by age. Determine the probability less than 18 years old, and the probability less than 18 years old and no health insurance. Are these events independent? Okay. So part A, the probability that X is less than 18. Should I wait? You're still copying?
Yeah, I'm almost done. Sorry.
That's fine. No.
Okay. Thank you.
Very good. Thank you. So how do we determine that from all these people, we select someone who is 18, who is less than 18 years old?
74094 over the grand total.
That's it. 74094 over 319457. Whatever that is. 74094 divided 319457. I got 0.231937. Okay, so let's see what they want here. Round to 3 decimal places is needed. So 0.232. 0.232. Part B. Okay, so in part B, we want to find the probability X less than 18, given no. Conditional probability, see this bar? That's the given as we write it. Okay, so this is this and this at the top, X less than 18 and no at the same time, and this is the probability of no. So let's start with the probability of no. Let's look at the table and let's determine the probability for no. Since I don't have enough room here, I'm going to move on to the next page. Can anyone give us the probability for no?
I think I know the answer. I'm going to take a guess.
Just a
is
no,
it-
so for everyone to see.
So is it 9711 divided by 508?
No, no is 5830 over the total.
Okay.
830 over the total of 319457. Of course, 319457, which will simplify. But let's take a look now at the top. This and this. This less than 18 and this at the same time out of the grand total. What is the intersection? So it's
9711.
9711. And of course, when we divide, we will divide just these two. 9711 over 50830. Whatever that is. 9711 over 50830. So this is 0.19104. Okay, so let's see what they want. Good. So again, 3 decimal places, 0.191. Finally, are these events less than 18 and no health insurance independent? Remember, we did this kind of example last time. If the events are independent, then the probability of less than 18 is this, and knowing this should not change the answer if they are independent. But this changes the answer to this. So knowing that they have no insurance now changes the outcome, changes the probability. Since these two are not equal, they should be equal if they are independent. For any new information, that's not going to change anything, but it does. The probability is different. So they cannot be independent. They must be dependent. Are the events independent? No, because the probability changes. Once I have some more information, the probability becomes something else. So they cannot be independent. Good. So that concludes this assignment. So now you have everything you need to know. And let's start chapter 6. Any questions for me? Is there anything else that you would like to go back to before we start chapter 6? You can